What if I told you there are more planets in our galaxy than grains of sand on Earth? And yet, amidst this staggering cosmic abundance, we have only ever found life on one tiny, fragile world, our own, a single, lonely outpost of biology in a seemingly sterile cosmos. This profound silence is one of the greatest mysteries of science, a paradox that has haunted us since we first looked up and wondered if anyone was looking back. But that profound silence has only fueled our curiosity. It has not stopped astronomers from searching. Across the galaxy, they are hunting for Earth 2. They're looking for a planet in what's called the habitable zone. This is the Goldilocks zone, a narrow orbital band around a star, where temperatures are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. Liquid water is the solvent for life as we know it, but a true Earth too also needs to be a rocky world with a stable star and a protective atmosphere. The search isn't just for any habitable planet, it's for a world that feels like home. Maybe even intelligent life we could talk to. 100 years ago, many experts thought this was impossible. Now, each new discovery brings us closer. In fact, some researchers suspect we may already have hints of life on distant worlds. So, what exactly is an exoplanet? Simply put, it is any planet that does not orbit our sun. For centuries, we believed they existed without any proof. That changed only when technology advanced enough to spot them. Back in the late 1500s, an Italian philosopher named Giordano Bruno imagined a universe filled with stars like our sun, each surrounded by its own planets. His ideas clashed violently with the doctrines of his time. By suggesting other stars were suns with their own worlds, he was implicitly demoting Earth and humanity from the center of creation to just one of countless possibilities. This wasn't just science, it was a direct challenge to the established cosmic and theological order. For this cosmic heresy, he paid the ultimate price. In 1600, he was executed, but his vision endured, a prediction of the truth we are only now beginning to explore. Today, scientists have confirmed roughly 500 exoplanets, with thousands more waiting for verification. Some defy imagination. There are super Saturns, with rings hundreds of times larger than our own, water worlds completely covered by oceans, and hellish planets where it rains molten glass sideways. There are even diamond planets, forged under immense pressure. And then there are the rogue planets, ejected from their home systems to drift eternally through the cold, dark void. And yet, these discoveries are just the beginning. Our Milky Way holds up to 200 billion stars, most with planets of their own. We have only examined a small fraction of the ones closest to us. But finding these planets is not easy. Stars are millions of times brighter than the planets orbiting them, making direct imaging extremely difficult, like trying to see a firefly next to a stadium floodlight from miles away. That is why only a few dozen exoplanets have ever been photographed directly, usually massive ones, far from their stars. The first big breakthroughs came using indirect methods. The radial velocity method detects the tiny gravitational tug a planet exerts on its star, causing it to wobble. By measuring this wobble, we can infer the planet's mass. This technique has revealed over 0 worlds, but works best for massive planets in tight orbits because they produce the biggest wobble. The real game changer was the transit method. When a planet crosses in front of its star from our point of view, the star's brightness dips slightly. This not only confirms a planet's existence, but also reveals its size. The true power comes from combining these two methods. With size from the transit and mass from the wobble, scientists can calculate a planet's density, the crucial clue that tells us if it's a puffy gas giant or a dense, rocky world like Earth. There's even a third technique, gravitational microlensing, which uses gravity itself as a lens to spot very distant or even rogue planets that other methods can't see. NASA's Kepler Space Telescope used the transit method to scan over 500,000 stars, discovering more than 80% of all known exoplanets. The most exciting part is that this method lets us search for signs of life. As starlight passes through a planet's atmosphere, certain molecules leave a chemical fingerprint. The Holy Grail is finding gases in chemical disequilibrium, like oxygen and methane coexisting when they shouldn't, as they rapidly destroy each other. Finding them together would be a powerful biosignature, strong evidence that biology is constantly replenishing them. One promising target is K2-18b, an ocean world where the Webb telescope detected possible traces of dimethyl sulfide, a chemical on Earth produced almost exclusively by life. It's not confirmed, but it's a tantalizing clue. Beyond these biosignatures, some are searching for technosignatures, evidence of technology, like industrial pollutants or the heat from a planet-wide city. And here is something to think about. If aliens 100 light-years away had technology like ours, they could detect Earth using the same methods. They could figure out our planet's size, its orbit, and even that our atmosphere contains oxygen, a sign of biological activity. Finding undeniable proof of life elsewhere would be one of the most important discoveries in human history. With new telescopes like the James Webb Space Telescope already studying these distant worlds, we're entering a golden age of discovery. Webb's infrared vision is perfect for analyzing atmospheres with incredible precision. And on the horizon, the Nancy Grace Roman Space Telescope will find thousands more planets, creating a vast catalog for future study. These space-based giants, working with massive new ground-based observatories, are an unprecedented toolkit for exploration. With this pace of discovery, many scientists believe finding proof of life will happen within our lifetime. This is not about finding a new home. Interstellar travel is far beyond our current abilities. It is about curiosity. It is about answering the question humans have asked for thousands of years. Are we alone? The truth is, the probability of finding life out there is impossible to calculate. But if we never search, the chance will always be zero.